Okie doke. So the fourth DHSS video, and it's the first of our simplified models introducing some growth. So a first step towards reality from the highly weird model in the original papers is to add knowledge growth. For simplicity, we make it exogenous, and of course we have positive depreciation. And then we test some different scenarios with respect to resource supply. And we start with a very simple scenario, which is that the resource supply R is exogenously fixed. So we can think of it as sunshine. Okay. You could also think of it as like hydropower or something. It's just a flow coming in an exogenous fixed quantity. We could also think of it as land, actually. So we just got a fixed quantity of land. I think I'll probably talk about land the rest of this video, which we can use as part of an input to production. Okay, and we get out y. Some of it we stick into capital. Some of it we consume. And we've got that y is ALL to the 1 minus alpha minus beta, k to the alpha r to the beta. We've got the growth rate g in AL, and we've got k dot, which is sy minus delta k. Okay, so we've got this fixed area of land added to a straightforward solo setup. What difference does that make? Let's see. We're again, as usual, we're not interested in transition paths and so on. We're interested in the very long run balanced growth. Balanced growth, k dot over k is constant, but from here we have k dot over k is s y over k minus delta. So that tells us that k dot over k and y dot over y must be the same because this is constant. Okay, so we got that result. Then we go up here, whoops, differentiate with respect to time and get y dot over y is 1 minus alpha minus beta times AL dot over AL plus L dot over L. So we can think of these as two separate terms, right? AL to this, L to this. And then we have 1 minus alpha minus beta times this, 1 minus alpha minus beta times this. Okay? And then plus alpha times k dot over k, which is the same as y dot over y, plus beta r dot over r. Okie doke. And we haven't said anything about population growth, so let's assume that is 0. AL dot over AL is just G. So we can simplify and say 1 minus alpha y dot over y is 1 minus alpha minus beta times G plus beta r dot over r. Okay, let me just pause the video here. Right, I was thinking, what do I do next? I've got a little bit of a headache. Not thinking quite straight here. What is r dot over r? R is just land, or the flow of sunshine if you like. It's constant, so r dot over r is 0. So we've got our answer. Y dot over y is 1 minus alpha minus beta g over 1 minus alpha, which is 1 minus beta over 1 minus alpha g. Okay, we're done. It's pretty straightforward. If beta is 0, we don't need the land, then y dot over y is g. That's just solo. The more important the land is, the bigger beta is, the bigger beta is, the slower is growth. We have this growth penalty because of the need for land. Okay, what about the price of land? So, can I squeeze that on here? I think I can. Price of land. How do we work out the price of land? We need to set up the profit maximization problem of one of these producers, right? And that is pi equals y. I should really write y out, but we have it in mind that that is y minus expenditure on each of the inputs. So that's WLL, WKK, WRR. Okay? And then we're interested in R, so d pi dr equals naught, which is dy dr, which is beta times y over r, beta y over r minus wr. So wr, r is beta y, which is the fixed share property, which I guess we talked about from the Cobb Douglas. I'm not totally sure right now, but land takes a share beta of the value of production, fixed share, and r is constant, beta is constant, so wr dot over wr is just y dot over y. The price of land grows at the growth rate. The quantity of land is constant, the price of land grows at the growth rate of GDP, which is more or less what we see in the data. So that's nice. So now we've got a model with some features that actually make some sense. We've got some growth going on. We've got a fixed input of land, which makes sense. Is a rough approximation if we're thinking about land. We've got depreciation of capital and so on. We can work out imbalance growth. GDP grows, but not quite as fast as it would otherwise if you didn't need the land, and the price of land tracks GDP. End of video.